In this video, I'm going to talk about Jefferson's method for apportioning the seats in the House of Representatives. Jefferson's method is one of the so-called divisor methods for determining an apportionment. So just to recap here, an apportionment problem is a fair division problem where players are entitled to differing percentages of a set of goods but must receive a whole number of items. And the items are identical and indivisible. And the traditional problem that we talk about in this scenario is the problem of apportioning the seats in the House of Representatives in the United States government, but we reduce it down a little bit. So vocab here, the standard quota is the number of seats that a state will receive in the apportionment, and the problem occurs when standard quotas are not whole numbers. So since a state cannot receive a fractional seat, we have to figure out how to handle this. Now this method was proposed by Thomas Jefferson. It was actually the first method that was used in the United States, and it was used from 1792 until 1842, according to Wikipedia. So here's how it works. To use Jefferson's method, first we must find the standard divisor. Remember, the standard divisor, denoted with a capital D, is always the total population divided by the total number of seats. So we will use the standard divisor to determine the standard quota and thus the lower quota. So we give each state their lower quota. If that does hand out the total number of seats that we need to, then we are done. But if it doesn't, we're going to choose a modified divisor, which we denote by a lowercase d, and we're going to use that to find a modified standard quota, and therefore a modified lower quota. We'll give each state their modified lower quota, and if that hands out the total number of seats, we are done. If it doesn't, we just repeat this process until we can successfully hand out the correct number of seats. So let's do an example here. I'm going to have 14 seats and 3 states. So this chart gives all of the information that we need. I've got state A, B, and C with their respective populations, and the total population is 11,200. So the first thing I need to do is find the standard divisor. So we just take the total population, which is 11,200, divided by the total number of seats, which is 14. Divide that out, and you get 800. So we're going to use the divisor of 800 to determine the standard quota. Remember, to get the standard quota, we just take the population divided by the standard divisor. So 5,800 divided by 800 is 7.25. You can round to basically whatever makes you happy, because we just need to get the lower quota, which is 7. So we're going to repeat the process for state B, taking state B's population and divide it by 800. We get 4.36. Lower quota of 4, and for state C we get standard quota of 2.38, lower quota of 2. So the standard quotas are always supposed to add to the total number of seats, and they will, more or less. If it doesn't add perfectly, it's because of rounding. But that doesn't really matter, because we look at the lower quota, and if we total up the lower quota, 7 plus 4 plus 2 is 13. So we have 1 seat left that we need to hand out. So that means that we need to choose a different divisor. Now since the total was too small, we handed out too few seats. That means that the standard divisor is too large. It's backwards from what you would expect. If the total is too small, the standard divisor is too large. So that means that D equals 800, our standard divisor, is too big. So we need to try a smaller value for lowercase d, our modified divisor. So let's go back to the problem here. I am going to pick D to be 600. There's nothing special about 600 except for that it is smaller than 800. So this time we're going to take the population and divide it by 600. So for state A, 5,800 divided by 600 is 9.66. Lower quota is 9. And we continue going through this for the other states. For state B, our modified standard quota is 5.81, lower quota is 5, and for state C we get a lower quota of 3. Now you don't need to worry about adding up the quotas that you get from just dividing by 600, because all we care about is what the lower quotas total to. And that's 17. But I only have 14 seats to hand out, so this didn't work. So as I said, we handed out 17 seats when we only had 14. This time the total is too big. 17 is bigger than 14. So, since we have handed out too many seats, that means that the standard divisor is too small. So since 600 is too small, we need to try a bigger value. But 800 was too big, so we have to choose something between 600 and 800. So how about 700? That's right in the middle. So same deal, we got to go through and divide all of our populations by 700 and then get the lower quota. So for state A, my lower quota is 8. For state B, my lower quota will be 4. For state C, my lower quota will be 2. And let's get the totals of the lower quota, which is 14, which is exactly the number of seats that I handed out. So the Jefferson's apportionment will say that state A gets 8, state B gets 4, and state C gets 2. So the divisor of 700 worked. Usually when you do this, it is a lot of guess and check. You have to sort of narrow it down. This is commonly known as the Goldilocks method of guess and check. This number is too big, this number is too small, this number is too big, this number is too small. And you keep playing with this until you have narrowed it down enough to get the lower quota to be the total that you want. So that's how we do Jefferson's method of apportionment.